Okay, testing. 1, 2, 3. Secret late night stream. Great. All good. Alright, once again, I have my scalding hot peppermint tea and my Pepsi Max vanilla on the rocks. And water. So, I thought rather than watching Babylon 5, I would do some programming before bed. So last time, we were trying to make function calls work, and it turns out that they were working by coincidence. Let's have a little looky here. So if we delete... Well, this program's not really going to work properly anyway. But this one will. So we'll run fixture 9. And let's have a look. Alright, so you can see we've got this main procedure, and we're adding 1,500. We're moving into RCX, which is the first integer parameter, 1,000, into RDX, the second integer parameter, 500, and then we're doing a call after we do some stuff to the stack here. However, this is just coincidentally working because we decided to use RCX and RDX as the first variable slots in a scope. So if we go and add something above this, run this again, you can see here we're going to have in RCX 42 and RDX 1000, which means the result of this program is going to end up being 1042 if... Yep, there we go. That is definitely incorrect. So, we need to actually do this part here. Set up the arguments into the correct registers, save any locals in those registers to the stack. Well, we should probably do that part first. So we'll say move arguments into the correct registers after saving locals in parameter registers to the stack if they're used. So what we want to do here, I think, is... So I'm not entirely sure how to do this. We could try simply pushing reg equals r, kind equals register. This is actually a unary, not a binary. So we could try making a unary op where we push each register that's currently in use. So we could do something like for r in use registers. Hello, Mfana Kagama. I'm sorry, that's hard to pronounce. How you doing? Hope you're having a good night or day, whatever time it is. All right. So what we could try to do is say if there is any of the registers used, actually not all of the used registers, it would just be the non-volatile, or the parameter ones. The parameter ones, I guess. or really any of them that you use, because we might want to use them in later scopes. All right. Well, I'm going to try just saving these ones first. I think I did this earlier. Here it is. So I've got the int registers and the float registers. We can say something like, if the register is currently being used, how can I pronounce your name? Can I call you Kagama? That's easier for me. But I don't know where the break in your name is because it's just lowercase. But anyway, you asked, are you writing your own backend? Yes, I'm writing my own backend. Right, so if it's currently being used. Actually, I shouldn't need to do both of those, right? Then I think we want to push this to the stack, right? Cannot index into this. Right, yes, of course. What am I doing? We need to look by int registers. So for rn. Okay, I'm actually just gonna handle this case first. This is not even correct anyway. Those are floats. Let's get rid of these for now. You're currently writing a language that compiles to .NET IL and generating it as strings. Oh, that's cool. I think I looked at .NET IL many years ago. It's an intermediate language, right? For .NET, for the VM. What does that give us? Cannot index into a bit set. Oh yes, of course. It's not a map. What's wrong with this? Oh, yeah. Keep getting that git/f coming up. Anyway, what do we got here? Operand is missing. Right, yep, because we need to pass in pointer to the state and use, that's not correct. I guess it's R. I just want to see what the output is. Invalid combination of opcode and operands, line 28. So it just says push and doesn't push anything. Interesting. So have we not handled push? Pushing is pushing the source. It's so cool. It gives me value types, struct and primitive, int, float, etc., and garbage collection. There are instructions for boxing from primitives to garbage collected objects. Yeah, right. Yeah, I actually do like writing VM code. It's pretty nice. Well, I like writing VM code when I get to also write the VM. I haven't really tried any other style. All right, cool. So this is breaking, which is good. That's what we want. You can see here we're actually pushing these values and then calling add, but that doesn't make sense because what we need to do is, well, I didn't even finish the code yet. So we need to push the values. We also need to figure out how to pop them back after the call. So we need to know how many were pushed. So would that be... We could have a stack of stack sizes. I don't know. Because if we call into a procedure and then we call into another procedure and then we call into another procedure, we have to know how many values are on the stack at each level that we're going to need to put back in to locals, I guess. I could simplify this by just never register allocating local variables, which might be a good way to start. Until I get more of a handle on things. So if we change this code down here, reserve slot, if we just don't reserve a register, it is of course going to make the program slower. You tried learning assembly a couple times and every time you quit in less than an hour. Well, now that you're writing something that compiles to an intermediate language, you're probably going to learn a lot more about assembly, even if it's that intermediate version. Actually, let me see. What does C# IL look like? It resembles high-level code. Well, it looks kind of high level. It's like kind of like in between, I guess. Yeah. So it's still got instructions: add, ret, load argument 1, load argument 2. It's a stack based. Okay. Yeah. So I think what I'm going to do in this instance is, for now, I'm going to only do stack-based locals. So what does that look like? All right, so yeah, I've allocated on the stack, these values, etc. And now when we call, we don't need to do, well, we still need int registers and float registers, but we don't need to save them. Instead, we're just going to do this part, move arguments into the correct registers. So we should have a parameter list available. I think we're calling add, so I need to look up add. Oops. So that should exist on procedures. And then node.token.text is the name of the procedure. Yeah. Procedure is this. What's actually stored in here? It's a node, okay. All right, so that's going to have data, proc, decal, parameters. That's our parameters. And our parameters are another node. Kagama asks, how long have you been a dev? I'm a final year uni student. I've been seriously making compilers interpreters since 2023. Well, I've been a developer. It depends what you mean by developer. I was a web developer from the time I got a computer when I was 15, I guess. I started doing web development at that time. I got my first paid web development job when I was 21. I think I was 21, maybe 22. So that was 14 years ago. But I only started learning systems programming in 2019. And that's when I realized that front-end web development doesn't teach you anything about programming computers, unfortunately. So parameter, I can't remember what the type of this is. I've got it here, right? It is... Oh, it's a parameter. The type name. Okay. So there's a type. I don't need the type. I need the... Is it just name? It is name. All right, so this is the name of the variable that we need to find, and we need to put this into REX. So we need to get the slot from symbol table. Kagama says, sick, I got into low-level stuff through exploring old GUI libraries, led me to renderers, and somehow ended up in compiler dev land. Yeah, that's funny. Seems like a lot of people end up in compiler dev land at some point. Renderers are really cool as well. I like building renderer stuff. So we've got a slot, and all we need to do is make unary push slot. So it's actually pushing from the stack. Can you do that? I don't know if you can do that. Because it's already on the stack. Oh no, we're not pushing. I'm not pushing. What am I doing? We are making a move into the first available register of the type that we need. So we need the type. I can't remember what the... Oh, okay, I just did this janky is integer type versus is parameter type. I just need to copy this code, I think. Yeah, literally, copy this code. Okay. So, yeah. I'll let you know my schedule is. Why is that on my... Why is that on my clipboard? Great. Lucky that wasn't something embarrassing on my clipboard. I was probably typing to someone in Discord. Okay, this is a little bit confusing. Okay, we need to bring this up, bring this in here. We don't need to create int and float registers again. We're not going to do that. Okay, so I've got the slot. We've also got param. Okay, so the register is going to be none. And then, okay, yeah. Okay, make binary move. So we're going to move into register. The value that's in this symbol table. I think that's right. Okay, is that right? Let's have a look. syntax error. Right, yeah, I forgot the closing parenthesis. Oh, yeah. Alright, unclared name I. Yep, that makes sense. So this will only work for Windows as sysv register order is different. Is my language a C-like with pointers and structs? Ask Kagama again. Yeah, it looks like this on the left here. I'll see if I can find some other examples. Well, they're all pretty simple examples right now. 02. Yeah, so like this, you know, struct. I think I might change this actually. I might change this to something like this. I'm not sure. Or I might even copy Odin and Jai and use this compile time binding operator. Not sure. But yeah, essentially slices, arrays, pointers, and procedures and structs. All the good things. So this is having a fit at some point and not working. So why don't we see what's going on? Oh, I know what's I know what's happening. If there's no parameters, let me see. What does the parameters look like? Oh, it's a dynamic array. Okay, well then that won't matter. That should be fine. If we can't find the procedure, maybe. Kagama says, is the brackets T a slice? Yes, pointer and length, that's correct. And you do that as well. What happened to the idea that fat pointers are costly? I never understood it. Well, I don't know. They take 2 registers instead of 1, I guess. I'm not sure. I'm not sure why people say that, really. Could be... Yeah, it could be because you need to stack allocate more often if you use slices. Because you'll run out of space. Like you can't fit... I guess you can't fit a slice into a single parameter register because they're 128 bits. I wonder if they need to be 128 bits. Probably should be. But yeah, what was I going to look up? Okay, yeah, so this is crashing. So I'm just going to build it and then run it and see where it crashes. We'll just get rid of the breakpoints. Breakpoints. All right. Crashed here because we're trying to look into this procdecal. This is not the right type of thing. We've currently got an invalid node. Yeah, because this is not a procedure declaration. This is... Oh, I guess we didn't get this back. All right, let's have a look. So if we look at the current state of the... I don't know what you call this. Lowerer? It's a really hard word to say. We've got no procedures. So by the time we process this call... Hey, Joe. Yeah, I'm streaming again. I decided to skip watching Babylon 5 today and do a stream instead. I'm on season 5 anyway. It's not really that good. I think season 1 to 3 is the best. And yeah, just want to get more done, you know? If I'm going to build a compiler by the end of the year, I go to mosey, as they say. Okay, so at this stage, we're trying to process a call, but we have no procedure at all. There's no procedures. Interesting. Well, let's have a look here. When we process a procedure declaration, yeah, I don't add it to the procedures, so that makes sense. However, oh no, we do. We add it right at the beginning here. When we call lower tree, whoops, from here, we get the procedures back. Okay, I'm just gonna go back to main, have a look at what procedures we get back, if any. No, it's null. Okay, I must have messed something up here, I guess. Wait, what are we even pausing? 09? Yeah, that's right. We got a procedure in 09. Kagam asks, what do you think about reflection? Is it cool and worth the effort? I still struggle with understanding how Odin implements the runtime type info. I think reflection is pretty useful for some cases. I guess for metaprogramming kind of stuff. I don't really use it much. I'm not sure. I don't really have an educated opinion about reflection. It's nice sometimes. Guess I don't do enough with it to really say. So let's have a look at this. Pause. So we should be returning parser procedures. All right, parser procedures. Okay. Right. I see. So we never actually add procedures anywhere. We should probably do that. Like here, I guess. Or at the end of this. What would this be? P dot procedures. And then where's the name? Name toke dot text equals n. Okay. Now if we run this again, do we get any procedures back? Yes, we do. We get 2 procedures back. Well, that's good. Okay, apparently it ran. Let's see what happens. Alright, so byte exceeds bounds, and we got the wrong exit code, but that's good. It's not crashing anymore. So let's have a look. Byte exceeds bounds. That'd be this. That would be these ones, right? Let's have a look. Out. Yeah. Yep. Line 27. And line 29. Yeah, so these have to be moved. I mean, I might as well just make them move keyword always, but it's gonna bite me later when I don't want to do that, I guess. Oops. Let's have a look. Move. Okay, so I'll just make a separate case here for move. So later we're going to have a size, but for now I'm just going to say keyword. I'm going to delete this, and this will just be move. All right. Kagama says they use reflection. Oh, I used it in my Java project for auto-wiring classes with response functions in a server. C++26 is adopting reflections, bringing up a lot of discussion about the subject. Right. Okay. Yeah, C++ is adopting a few things. Something that I actually want to put in this language that C++ is adopting is contracts. But probably not exactly how they're doing it. Okay, so that's fine now. We got the assembly, but the exit code is big number. What's this? Buffer was changed. Okay, that's fine. Okay. So we're returning the sum of these two numbers, but that's not actually what we're doing. Let's have a look at the assembly here. So we're moving onto the stack the number 100, 1000, 500, and then this doesn't even make sense. How does that even compile? Move keyword RCX, RCX, move keyword RDX, RDX. I mean, I suppose it makes sense. It just seems kind of redundant. Kagama says, oh, contracts, I've seen them, but they look horrible. Pre and post, they should file for syntax bankruptcy. I like the new ranges, though. Yeah, I'm not sure about the pre and post either. I don't know exactly how I'd do it. I haven't seen the new ranges. I am actually tired. This is going to be even harder. Oh well. Let's do it. So. We have now these values on the stack, but for some reason, it thinks that it's in RCX. So let's have a look. We're setting up the symbols. Right. So yeah, that's the problem. Wait. No, that's fine in the procedure declaration. It's actually here. Variable declaration. Lower this node. We get back a slot. What slot did we get back? I'm going to print something. No, I'm not going to print something. I'm just going to run it in the debugger. Where is that? IR 216. Let's do it. Okay. So, what I want to look for at this stage is what are we actually putting into the symbol table. Let's get rid of these. All right, so we've got a slot back for some variable. The value is 8. What's our code look like again? Let's have a look at the code. The value is 8. Why is the value 8? For a variable declaration. What's the node look like? Okay, it's an identifier Z. The value is definitely not 8. Just interesting. Okay. Oh, right. Yeah, this is the... No, this means it's stack allocated. That's right. So that's how I set it up. So it's at offset 8 on the stack. That's fine. So that's where it's going to go in the symbol table. If we look up symbols. Oh, ir.symbols. And then we go to the next line. We should have something in here. Oh, there's a few things. I don't know how to actually look up the values. Can I just... I doubt I can index into it like this, but let's try anyway. Cannot index into this type, yeah. That would be cool, but wouldn't expect that. Let's have a look. All of the keys. How big are these? It's very big. Wow. Hang on a second. That doesn't make sense. Where's the length? The length is 3. I don't know how to look at a map in the debugger. This is bothering me. Dot... Is it value cell? And then... What is this? I want to look this up. Let's have a look. So... IR symbols, value cell. Okay, that's nil. Is that not a thing? I thought I was just looking at that. Huh. It's oh, under data, right. IR symbols data. Okay, so I see some values here, but I'm looking for Z, which is... What is Z in hex? 122. I don't know how to cast this to hex. Probably not like this, right? Yeah, I can't do this in my head. I don't think it's here. That's definitely not, none of these are Z. So, alright, I'm just going to go to the next case. Next case is, yeah, next case is, what did we get? Node A. And we're putting that in slot 16. Yeah, that's correct. So that's fine. What's actually the problem? Yes. When we look it up, we're getting RCX and RDX. So let's have a look at where these instructions are generated, which is in call. Oh, yeah, that's the problem. I didn't change this. Oh, duh. Okay. So it's just looking up the register. We don't want to do that. We just want to get the slot and then move it into... Oh, no, we do want to do that. Hang on. No, that was correct. We want to move into RCX, but for some reason the slot that we're getting back from the symbol table is also RCX. Why is that? Okay, so IR339. Let's have a look at that. 339. Here we go. Okay. No, thank you. Go away. All right, so we're looking at the procedure. What procedure is it? Add. Okay, that's fine. Looking at the procedure add. And we've looked up the symbol for X. Actually, this is totally wrong. Yeah, what am I doing? This is just wrong on the outset. Okay, we don't want to look up the procedure. We want to look up the call, which we're already looking at. So if we look at the call data here, it's got arguments. That's what we want to look at. We don't want to look at the parameters. Okay, so an argument is a node. I probably made it a parameter type, didn't I? What is it? It's an argument. Okay, but what what does this mean? Parse expression. I don't know what data type it is. Huh. Interesting. So it would be node data call args. Just going to comment this out, and I'm going to say something like print line. Oh, I just want to look at this open run code. Where is it? Here. Okay, so we've got an identifier, A. Right, okay. So we're going to have to figure out how to lower this, I guess, and then store it in RCX. I think that's what we need to do. Because it could be, for example, A plus B, and then what does that give us? That gives us a binary op, right? So we can't just put the binary op in there. So we need to lower it. Okay. All right. So, I think that should be fairly straightforward. We should just be able to pass this in to lower, and then we get back a slot. Now let's see if that works. So we got back somewhere on a stack value 24, and then we also got back somewhere on a stack value 24. That doesn't seem right. They can't both be at 24 offset on the stack. Interesting. But okay. Okay, I need to run this in the debugger again. Oops. Okay, here we are. Are we at this position? Yes. All right. So I've just got back our first slot. It is on the stack 24 offset. So let's have a look at this. RSP. No, that's not how this works. This is the fake stack. This is not, we haven't actually compiled the program yet. We're in the middle of compiling the program. So I actually need to look for nothing in that scope, I guess. IR stack offset. So it's minus 40 at the moment. Oh, my monitor just turned off. Just a second. Hopefully it turns back on. There we go. All right. Okay, so we're at negative 40, and then we run again for the second argument. Did that run? Oh, it's running the whole program. All right, so we hit a breakpoint. I can't look at what argument is. Interesting. Okay, so I know there are two of them, but it won't show me. I'll put the breakpoint here. Probably because I'm at the end of the scope. There we go. All right, so we got the argument, which is plus. Okay, that's the binary op. The slot that we got back is 24, and the stack offset's negative 40, and then we run it again. And once again, we're still negative 40 stack offset. And we got back B. So that doesn't make sense. They can't both be at the same the same slot. So something is not running. So we'll run through the first one. Okay, we're lowering a binary op, right? Yeah, lowering a binary op. Okay. Oh, I didn't actually go into this, but anyway, plus, and then we add the instruction. So I probably needed to go into here. All right. Wait. Okay. Lowering the left side. Oh, it exists? Right. Yeah, that's going to be a bug, I think. So what's happening now is we're saying, let me look at this. So we've made space for A on the stack, and now this binary op is saying, oh, A exists on the stack, so I'm going to return that as the slot that you're going to use. Okay, so that's the source, and then destination is going to check, does the slot exist? Yes, because it exists on the stack. B already exists at this position. Okay. So we've got back source is 16, dest is 24. That's fine. But then what happens? Then we append the instruction and we return destination, which is 24. So why do we do that? All right. I'm 99% sure that's incorrect, but what I'm going to do is just ignore it for a second. Uncomment this. Run this. I can't. This is different. This is not supposed to be parameter. It's call. No, I can just do arg name, I think. All right, doesn't have arg dot data dot. What is this? Oh, it depends. It's kind of annoying. I can pass in the token text. Okay, none is not defined, so we've made some problem here where we've got none, and we're also moving, as I suspected, the same variable onto the stack twice. Okay, so these are coming up as the same address because we return destination rather than I guess putting these somewhere else, because this is its own expression. So we might want to actually Frank asked, what did you find more helpful, crafting interpreters or the Jack Crenshaw tutorial? I think for me it was the Jack Crenshaw tutorial was more helpful, but that's because I just think it's my learning style. It was more I don't know, getting your hands dirty and also trying to figure out, because I had to translate it. I think it's written in Pascal or Turbo Pascal. And so I had to translate it into C, and doing that translation process helped me learn more as well. But I think it's incomplete. So crafting interpreters is complete as far as I know, whereas the Jack Crenshaw one is incomplete, I think. All right, so I think the problem we got here is what I thought we were going to have an issue with originally, and that is we need somewhere to store the result of expressions. Joe says time for a run. All right, nice. Have a good run, bro. I didn't know you did running. That's cool. Okay, I need to get my bearings here a little bit. So this should work, I think. But I guess I haven't tested it with named variables yet. Let's have a look at what it... I'm going to delete this other code for a second. Aviv Beery says, Crafting Interpreters is a great book, but it's more of an introductory text. It doesn't cover code generation and optimization, which isn't ideal if you want to lower to machine code. Whoops. Oh god, what did I do? I went to the help. Yeah. I mean, I don't think I've read anything about lowering to machine code. I'm just kind of trying it. I read... No, I did read a little bit about the 3 address code thing. Okay. So, in this case, we've moved onto the stack because we're just doing stack allocation now. Right. Maybe that's the problem. Yeah, so we can't do this. We can't add 2 stack values together. We've got to get them off the stack and then add them together. That's one problem. Okay. So this is because we just changed from using registers to always using the stack for locals, because I thought that would make it easier. So this would be in the... Would this be an emit? No, this would not be an emit. This would be in IR. Yeah, here it is. So we basically need to have... If we're going to emit an add instruction, or any binary operation really, we need to make sure that the destination is a register. So if the destination is not a register, then none of this is going to work. Kind of annoying, actually. So, whoops. Maybe I don't want to do this thing on... Maybe I don't want to comment this. All right. Move into RCX 42, move into RDX 40, add RDX, RCX. Yeah, that's, I mean, that works now because we're actually using the registers. But now it makes the call problem complicated again. But maybe that's fine. So what we want to do with call is basically push all of these values to the stack if they're currently used, and then pop them back off at the end after we do the call. Okay, I guess we can just make a little local. I get confused because I keep thinking as I'm editing the compiler that the compiler, this part of the compiler is running the instructions, but it's not. Right? It's just determining what the instructions are going to be. So if I make like an array here of the registers that we're about to use, for example, called push registers or something, and then I just delete that at the end, and I also need to wrap this, defer it. I can just access this at the bottom of the call and then pop them off in reverse order, right? That should be fine. So I've just got to go through the currently used registers at this time. Actually, no. Got to do this for rn int registers if rnir dot used registers. So we're keeping track of the currently used registers in this bit field or bit set. No, we don't need to do that. Then append pushed registers are okay. And same for float registers. Although I guess this could just be whatever. Registers we need to restore. Okay. And at the bottom here, we can just say restore locals after call. Yeah. Okay, so we can push the registers to push the registers at the top, and then at the bottom, we align the stack, allocate padding bytes, call, and then deallocate the stack. Okay, and then here, pop values back into registers, right? So we actually have to make the operations happen here as well. So make push reg equals R. Okay. And then at the end, for register, or for R in pushed registers, but we want to go in reverse order, right? Oops, reverse. Then we want to make unary pop kind is at the register. Man, I'm tired. Maybe I shouldn't have streamed at this time. Oh well. We're deep in it now. Cool. Okay, I think that is going to work. I didn't think about this part yet. Let me just see what that does. It's all broken because why? Ah, because I gave this a size. Okay, XMM0 cannot determine type for explicit selector. Huh? Oh. Okay, oh yeah, and int registers, float registers, etc. I'm just gonna comment this part for now. See what we get. Alright, so I'm moving into RCX42, into RDX40. Well, of course, we didn't even use the stack, so... Wait, oh, we didn't call. We didn't call, so... Let me just undo this. Okay, first we'll try to get this working. Then we'll do the more complex thing. Alright, what have we got? Hey, cool. It's pushing RCX, RDX, R8, and then popping R8, RDX, RCX. Is it the right order? So adding to RSP40. Okay. Then sub RSP. So that's for the return address. That's right. Okay, I think that's going to be the correct order. Obviously, this is incorrect because I'm moving into none, RDX and R8. But that doesn't make sense because... Aha. I need to also make these registers not used anymore. Which I guess means I have to reset it here. I don't know, this seems like it's going to be very error prone. And then down here, registers equals, plus equals R. Okay, that's wrong. Still. Fine. This is okay, I guess. So we're using RCX, RDX, R8. That's correct. All right, that's all fine. But we're not supposed to move into RDX and R8, so what's that about? Where is that? That's this code here. So the problem is register is register. Where did register come from? It says none. Oh, from RDX and R8. Okay. That is actually correct. Okay, that's correct. The problem is we haven't got the correct registers yet. And I deleted those. I should probably just make these a global or something. But anyway. What do we got now? Move. No, why is it still none? Why? I need to look at what this is actually doing. If it's not an integer type or it's not a float type, then it's not going to work. And I don't think that the type information is included in the text. So that doesn't make any sense. We need to pass in the actual argument is node integer type. Alright. Make some hunky-dory procedures here to have a look at the node, returns a boolean, and we just want to make sure that the node that we're looking at is an integer. And how do we do that? Can't remember. Got to look at the node type. So there's a node kind. If the node kind is a number, then we're on the right track. The thing is, We really could have separated number and float, or integer and float at this point, but instead we've got some silly thing where we have number, which is a union. Whatever. I might change that later, but for now we can say if n.kind is not equal to number, do return false, and otherwise n.data.number case int return true. No, I guess, yeah, that's fine. Return false. Actually, I should change this. If it is a number, switch, and otherwise return false. Okay, so that should work, I think. Whoops. And same thing for this, but float. Wait, no, F64. Okay. Is that gonna work? No. Partial switch. Yeah, of course. I always forget about those. Alright, what do we get now? Ooh. None. Darn it. Alright, let's look at what's going on. Okay. Maybe there's no type information at this stage. I don't know. Let's find out. So, we'll build this. We're going to go down to... I guess we'll just check in here or here. Where are the other breakpoints? Let me turn them off. It's that one. All right. So we'll run this code. All right. So we're checking this node. What is the node? Let's have a look. It is... Oh, we have to step into procedure. So we've got an identifier. Well, that's the problem. It's an identifier, A. And there's no... Of course, I'm silly. I have to look it up in the symbol table. Right? Yeah. So I've got to look up the symbol, which is an operand. And an operand has some data, like either it's either an immediate or a float, or other things, but yeah. Okay, so if symbol.kind equals immediate, then it's an int. Else if symbol.kind is did I call it float? Yeah. Float registers, then we can get rid of this and that. So this should be fine. Just gonna put this here. And why is this note not highlighted? Is note not a highlight thing? Okay, sure, whatever. Okay, we're still getting none. That's not good. I was sure I had it that time. Of course, these breakpoints don't work because we don't even call these anymore. Let's have a look at what this gets back. Symbol is RDX. Oh yeah, it's not symbol, it's location, basically. Which also doesn't tell us the type. So A is currently stored in RDX, but yeah, that's a register. So yeah, we have no type information here. All right. It's weird because is there no type information? Maybe there's no type information yet. Maybe I just didn't do that. Let's have a look where we store symbols. ir.symbols whatever equals blah blah blah. All right, so yeah, okay. So when we're storing things in a symbol table, we're not actually telling anywhere the type. That's not good. We should probably do that. All right, and we don't have a type table or anything. And we're going to look up the types. And I think we're probably going to run into a big issue with just directly inserting stuff into the symbol table here, unless I think we should make a procedure to do this. Because that way, at that point of the code, we can check, oh, is there something already in here with this name or something else, right? So this looks up something in the symbol table. This looks up something in the symbol table. This adds something to the symbol table, which is parameter list. So for the parameter list, this adds something to the symbol. What? Isn't that the one I was just looking at? Oh, yeah. And finally, this one, variable declaration, adds something to the symbol table. But there's no types in there. Yeah. So, where do we put types? I guess a symbol should probably not just be an operand, right? Operand kind, register, value, float. So why is there a float kind in operand? What is it for? Oh, it's for a move instruction. So we know we're moving into XMM0 or something like that. I see. Right. That doesn't really help us in this case. Okay, right. So this is for a float literal or integer literal, memory location, register. Yeah. That has nothing to do with types. So maybe we want to add types, but this is all scope based. Like the symbols. What do I even do with the symbols? Are the symbols just globally added to? Yeah, it looks like it. I just override them. There's no scope for the symbols. So as soon as it hits A or X and Y, these symbols, I guess, are the same as if I had an X down here. It would just shadow it. Not good. Not good. So we need some concept of cascading scopes, I suppose. Could be symbols. Symbols. Why is this familiar? Have I done this before? I'm getting some latent memories of like a stack of symbol tables. Is that a thing? That would make sense, actually. All right, and then you would add, so you'd have the main scope, which would be your first I don't know, first entry into the stack, right? And then any procedures, but they would have their own They would have their own scopes that are not necessarily higher or lower on the stack than each other, so that doesn't actually make sense until you call into one, and then that would be higher on the stack or lower on the stack, whichever way you want to look at it. Oh man, I'm probably overlooking something really simple here. So, symbol table obviously can't work like this. To do check for shadowing, yes. So I'm going to actually just down here put x is float, that is the value 123.0, and now what happens? Well, I didn't understand that it was a float for one thing, which is interesting. But when we refer to, oh, I don't want to do x. I want to do something like adding a and b here. But what if it was a and b up here rather than x and y? Okay, so in add, we've moved... Wait. I don't even see the parameters here. Add RDX and RCX. Oh, that makes sense, actually. That makes sense. And then move into RX, RDX. That makes sense. And then down here, RCX, RDX. Well, that could just be a coincidence again. I don't know, I'm getting confused now. Okay, move keyword none. Obviously we need to fix that. Did I not save this? No, I didn't save it. So the problem is at this point, there's no type information, right? That was the problem. Because this is only telling us if it's an immediate value. But it would be. This is an immediate int. So is that. Okay. Okay. That's why I don't code at nighttime. Right. Why only program during the day after you've had some exercise or something. What? Alright, didn't look it up yet. Alright, so we found the symbol that we're looking for, which is... what is it called? A. Okay. We found symbol A. It's sitting in register RCX. Forrest Bittle, good morning. How you doing? Hope you're having a great morning. So it is a register, which means it's not an immediate. Because now we're looking at the place that it's stored. Not the value. What about this? What does this say? Register RCX. Okay. All right. So really, at some point, when we're adding a symbol, we've got to add the type, I think. So I'm going to say add symbol, and I know that we're going to have to change this because there's no concept of scopes in this. But what we want is, I think, name and type, which I guess should also be a string. And we're just going to add that to the symbol table. And do we need to return anything? I don't think so. Maybe if it was successful. So we've got the symbols, which is currently operand, but I'm going to actually make a new type for it. So we're going to have literally just 2 strings. I'm not sure about this. Because... okay, so there's the symbol, and then there's like where it is. So that would be the operand, I guess. Alright. So we're going to say symbols would be indexed by name, and we're just going to create a new symbol. I don't know if we need to store the name again, but anyhow. Okay, this is the dumbest thing ever. It doesn't even check for shadowing. It's just going to return true. There's no scopes. But we'll start with this. All right. Symbols, blah, blah, equals. Let's find this. So instead of this case here, we're going to say add symbol. And it's going to be p.data.parameter.name. And the type, so I'll just name, type, and operand. This is the operand. This is the name. The type is, well, maybe I should use the value type that I've got here. Name, kind, length. Yeah, I should use this rather than a string. Because it's got extra information, like if it's an array, then it has the length. If it's a pointer, it tells you that. I think. Yeah. Or if it's a slice, etc. Okay, so that's... We should do that, yeah. Okay. So we need to get the type from the parameter. I'm pretty sure it's just parameter.type. Yeah. Whoops. All right. To do check for shadowing should be here. To do make symbols have scope. So right now they're just all floating around in the same scope, I suppose. So they're just going to override each other. All right. Now we'll search for anywhere else we've assigned something. So instead of assigning this, we will have to get the name. And the name is no.data.vardecal. No, actually, no.token.text. That's the name. The type. That's an interesting one. We don't know the type because we haven't done type inference yet. I guess we need to infer the type. Okay, let me look at what we're getting back first. So we're on line 228. Oh yes, right, I broke the whole thing because operand of type operand is missing. Yeah, right. Going to be a lot of errors to fix. Symbol has no field kind. Did you mean type or name? Etc. We'll leave these broken and 228. Ah, yes. Name equals no dot token dot text, and we're not going to assign. Actually, we should probably just use this. We'll pass in an empty type because we don't know it right now. And the operand is slot. All right. What was the other error? Return, can't return symbol to operand 324. That's going to be here. Right. Yeah. Symbol dot operand. All right. What do we got? One more error. More errors. Hang on a second. Right. Okay. There's quite a bit of... Actually, I'll just run this. Quite a bit of messing about. Messing a boot indeed. Alright, so we've got... the same problem as before, which is not unexpected. Yeah, actually I did want to run that in the debugger. I can't. That's weird. Must have been deleted or something. Alright. Excuse me. Thank you. So we're going to lower until... What do we get back out of that? We've got a symbol A. It's got no type because we don't know the type. But we know it lives in RCX. All right. Now, if something tells us it's a U32, we should probably take it seriously. So how would we do that? We would say in the parser, when we're sorting out the value type on a... What? Where is it? Not a procedure declaration, variable declaration, right? So it's got the type. Type is a string. Oh, that's not good. Let's see. It doesn't even store the type. Consume the sign. Oh, this is the wrong one. Typed variable declaration. Here it is. So the type token, expect an identifier. Okay, and then we're just storing it as a text. Well, I think we can do better than that. How do we make value types? Parse value type. Yeah. So why don't we do that? Instead, so that gets the... Alright, so it parses slices, pointers, arrays, types, and whatever built-in types we have. Okay, sounds good. So really all I need to do is call this here instead of expecting an identifier. What does it return? A type, okay. And then we can set this type, whoops, to be an actual type. And what's it going to break? Let's see. Let's see, what did we get back? We got, where's the AST? Oh, it's at the bottom. We got, okay. Parameter U32. There we go. Variable declaration, types U32. All right, that's good. It's not printing correctly because the printer is set up for this other version where we just have a text type. So we probably just want to, I don't know, print that for now. It's really messy, but whatever. So we've got the type U32 and U32. Why don't we change these? One of them can be a U64, which obviously we don't want to actually make that compile, but it does change it here, so that's good. All right, so these are supposed to be built-in types, but we'll add that later. But the good thing is now we have type information, at least a very primitive version of type information. So on this variable declaration, hang on a second, this variable declaration and there's assignment. Oh yeah. Okay. Oh, it is just variable declaration. Yeah. So they're both variable declaration. One has no types because it's inferred. The other one has types. All right. So we probably want to do the type inference here on the parser, I guess. So we say something like, because we don't know the type. No, we can't do it here. I think we need to do it in IR because we need to figure out what the right-hand expression actually is. Oh, we do that here. But, I mean, we could do a really simple version here. So if we get back, for example, if I just call this like right-hand side, and we could get back like if right-hand side dot kind is number, then we can do a really simple, like, is it a float or is it an int? Do something else. So this would be type equals, it's a value type, right? Value type has name. Well, the name would be whatever the name is. Untyped int. I need to look at this type again. I keep forgetting what's in my structs. Where is it? It's not in here. Here it is. I really need some kind of lookup functionality. I know there's an LSP I could add, I just don't want to add it. Okay, kind, value type kind. I forgot what these are. Right, all right, none/slice array pointer. So probably just none, I guess. Since it's a number, and then we could store the number at this stage, but I'm not going to do that. So I'm just going to say if it's a number, it's an untyped int. That's not strictly true. We could figure out at this point if it's a float or not. I just want to see what we get. Oh, we need to actually add something like x. 42. Alright, so yeah, we get untyped integer. That's cool. Now if we put y is 40 point to, we're going to get untyped integer again, which is wrong. We might want to call this... Do I want to do it at this stage? Maybe, yeah. Let me search for this. How is that not found? Okay. Here it is. Parse number. Given the text. Yeah. So we could just do that here. And we get back these values. Okay. It's quite a few variables to get back. So we get back is float. If there's a float value, integer, and did parse. I'm going to get rid of did parse. I think we actually already must parse this when we're parsing the expression at some point. Maybe I should look at this. I'm going to look at this data here for a second here. Can I do... I can. Runtime. Debug trap. I forgot about this. So useful. So now I can just get rid of this, run the program, and it's going to do a trap here. God, that's useful. How did I forget about that? Anyway, let's look at what we got back for the right-hand side. My screen turned off. Good timing. All right, we're back. So we got back the number 42 as a string, and it says it is a number, and it's got a tag here, so it knows that it's an int at this stage. Yeah. Duh. So we don't have to set it to an untyped int. If it's not, we can say switch ihs.data.number, or rather v in. Check the union type. If it's an int, then do this. Otherwise, if it's f64, set it to an untyped float. Okay, pretty primitive stuff, but should be giving us the right types at least. There we go. All right, so I've got untyped int, untyped float, u32, u32. Nice. All right, cool. So, what are we even doing? I think we're trying to get type information so we could figure out where these variables are or something. I'm lost again. All right, so none is not defined. This is still outputting incorrect values. Yeah, but we have type information on A and B. I guess we want to look at this. So we get the symbol out. I really need to make a build script, even though it's not hard to type that. It's just kind of annoying. All right. So we got a symbol out. It's an A. It doesn't have a type. That's right. So that doesn't have a type at this stage because we gave it an empty type here. But at this stage, I can't type apparently. Wait, what? Ah. One time. Debug trap, there we go. Run this code, here we go. Okay, so we got our symbol. Yeah, so we got our node. Let's have a look at it. So I've got a variable declaration node here. It's got some data. And it says what? It's the value A. It's a number. Tag 3. Wait, what? How does that make sense? No, it can't be that. It's variable declaration. Yeah. Type, U32. Wow. Okay, we've got a type here. Nice. So that means we can pass it directly in. So it's node vertical type, right? Oh, geez. We're going to have some issues in the future with things that don't know their type yet and all kinds of hairy stuff, I'm sure. But for now, let's step into here. We say, okay, we're putting in this symbol. What are the locals? Show us the locals, eh? Show us them locals. All right. We've got a U32 stored in RCX. Very nice. Name is apparently not available. Okay, the name is A. I had to go to the next line. Cool. All right. That's great. Now that we have the type stored, we should be able to look at it at this point before we call a procedure. And I don't even remember why we're doing that. Oh, to put it in the right kind of register. Yeah. All right. Okay, so we got an A. It's a U32. Okay, cool. So what does this actually mean? It means it's a... Wait. It says value type kind none. I must have messed something up on the way. Let's have a look at the parser. Yeah. So it's an untyped int in this case. Because this is type inference, and this wasn't even related to what we were doing. We're doing this one. Okay, so we got the type, parse value type. All right, and then we get back, yeah, whether it's a float, integer, or whatever. And then kind. So let's have a look here. Oh yeah, so kind is none. That makes sense. Oh, I see. But we still we still don't know if it's an int or a float at this point, unless we look at the name. Oh, that's silly. So I guess we should use a union here. Because then we can... Then we can just add these types. Probably going to have to add more data to them, not just int and f64, but now it's going to break everything. And we have to rewrite a bunch of stuff. The Linux TV pen, welcome in. You're new here. Sorry, I'm new here. What are you teaching? I'm not really teaching. I'm kind of teaching, not exactly. But compiler development. We're making a programming language. So, okay. We've just broke everything everywhere, which is cool. Wrong file, I suspect. Yeah. Alright, so in the parser line 216, we're going to have to set this. The Linux TV pen says using C, right? No, this is Odin. What's wrong with this? can't assign a value to it. Why not? Oh, do we just set it like this? Yeah, that's how you get the value out. Okay. Right, so in this case, there's no type name. No, there is a type name. There's no length. It's just value, except we don't value int. So it would be like that, yeah. Oops. Okay, cool. We've got a crash. Let's see what the crash is from. That's not the crash. Well, that is the crash. Oh yeah, I have a trap in here. So of course it's going to crash when I run it. Anyhow, what do we get out of here? We got a type, we got a value, tag is 0, value is 0. That doesn't seem right. Okay, that's good, that's good. I need to check at... Where was the other one? Go ahead, delete the other debug trap. Yeah, it was in var_decal here. Maybe I'll add one here. Alright, so adding a symbol A to U32. The value is 0. Why is the value 0? Ah, is it this one? Huh, I should rename these. Just to be absolutely sure which variables we're talking about, because there's no scoping, as I was saying before. Alright, so we are talking about A. Okay, good. So, alright. Why is there no value? Wait, let me see. Where did it come from? It came from... here. Alright. Okay. So operand is this. That's fine. Type is... Right. So it came from parameter types. So there's parameter types. Yeah, of course there's no value. But why is it called A? It should be called X. This is pausing procedure declaration, yeah. Let me have a look. So this is, it is X. What? But then when I go down here, it says it's, oh, now it's X. Okay. All right, maybe that was just some stale data from last run. All right, so X and Y, we expect those to have 0 values because they're parameters. However, A, we expect to have a value, but it doesn't. Where did it come from? Variable declaration. Okay, so U32, it's got no data, no value. Okay, that's not good. That's coming from the block, that makes sense. Coming from the body of the procedure, which is coming from the file. It's coming from here. Yeah, okay. All right, so for some reason A doesn't have a value by the time it gets here. So let's look at the parser again. And we're going to look at parse value type. Okay, so something broke, I guess, at this stage. Let's have a look. Why did we not get... Huh. Oh, I only covered one case. Wait, if it's a slice, do this. If the next kind is a number... Okay. If... Oh, right. Whoops. Yeah, so I think actually this is the case that we need to parse the number, but we're not doing that. So... Right. Let me just make sure that's the case. I'll put a trap down here. I think that's where we're actually running into the problem here. Yeah. So what is this? Current. Well, it's going to be nil. All right. P pos is 4. That's this. No, 0, 1, 2. That's this one. Okay, we're looking at that. And U32. Yeah, right. So it's just saving the text. Right. But we need to also save the whole, you know, type. Wait, no. What am I talking about? That's fine. That's fine. That's fine. If this is a left bracket, but we never hit this. So where are we doing this number handling? Parse value type. Variable declaration. Right hand side parse expression. Yeah. That's this one. Oh yeah. But this one, yeah, this one does pass the value type. Okay. Let's have a look. Okay, so pass this value type. And we get back 0, yes. That makes sense. Because it's a type. It's not a value. God, I'm just retarded right now. What? I'm looking at the types, wondering like, why is there no value stored in the type? Of course there's no value stored in the type. That's not how it works. Value is stored in the value. Stored in the expression here. All right? So, let's look at that. All right, so we've got the expression, which is a number, right? With the value 1000. And if we go down here, it says value, number, and it's a number, it's an integer with the value 1000. Yeah, dir. So okay, if that's the case, then what the hell was I looking at in this case? The type. Right. Okay, so we get the expression, and then we also pass the type, the value type, but this doesn't account for something like, you know, if vt.name, I'm just going to write some procedure, is integer. Actually, we already have this in, where is it? Is integer type. Yeah, this. So if it's an integer type, then we should say that. We can say that at this point. vt.kind, no, vt dot, we don't need to give it a value, we just need to know that it's an integer. Do we need to know here? No, we don't need to know there. Okay, what are we looking at? Once again, we're looking at X, Y, A. Okay, we're looking at A. We've got the type. We know it's a U32 at this point. Okay, that's cool. It doesn't have the value. That's fine. The operand is where the value is. It's telling us it's in RCX. So if we look at RCX, well, it's a pointer. Probably because we just call the... We're not running the program yet. We're not running the program yet. So of course we don't know that, but that's fine. It should be an RCX at this point. That's fine. So what even is the problem that I'm solving? I'm like totally lost now. Odin, run, code, and run. Okay, right. I left debug traps on. Let's find this one. This one. Alright, so the problem is we're getting none here. That was the problem that we were trying to fix originally. And that's coming from this code here. Because I was trying to figure out whether something is an integer or a float. That was really what we're trying to do. Alright, so I'm going to enable this trap again. Have a look at this state. Right here, iPlaysDev. Hello, how you doing? Welcome in again. Good to see you back. Okay, so I'm not going to worry about this. Actually, I can see that it's a U32 from that type. Did I decide on the name? No, I have put no thought into the name at all since yesterday. Crap, what was the... Can't remember what the field name was called now. 1 second. Symbol, oh, it's just name. Wait, that's not what I want. I want the symbol type name. Alright. There we go. That's what I wanted. This whole time. I think. I don't know if you guys have ever heard that it's probably better to get good sleep and then just program in the morning. I think that's correct. I gotta get rid of this. Run code and run. Oh wow, the program is working. Would you look at that? Cool. Okay, we gotta add some stuff to it to make sure we need to break this basically. So since variables don't have scopes, I'm just gonna add random letters here. We'll figure out how to add the scopes next time, I think. But we are getting 1500 returned. And we are, let's see, moving into RCX 42 and then 40 and then into R8 and R9, these values. Pushing everything to the stack. And then moving into RCX and RDX before the call, the values from R8 and R9. Call and then pop, return. That's good. Desio Gamer, welcome in. Hope you're having a great day. What language is this? It depends which this you mean. I'm programming a compiler using the language Odin. This language here is, well, I guess it's NetWide assembly, so 64-bit assembly language. And then this language here is the language that we're making. All right. Wow. That was a mission, guys, I've got to say. A mission. All right. What time is it? It is 10:30. I might have to actually call it there, but I know exactly what we're going to do for next stream. So we did get this working. So actually, we can add multiple variables to the scope, and then it keeps track of where they are. And then when these ones get called, they get pushed into the right registers or moved into the right registers, and etc. And then we return the number. So in this case, A plus B, and the program prints 1500. Right? That's all we want. Desio Gamer says, "Wow, so you're making a programming by your own?" Yeah, I'm making a programming language. That's right. So, that's good. But for the next stream, I know exactly what we're going to do. We're going to have to set up scoped variables. Because right now, it's kind of hard to tell just reading assembly and stuff. But basically, if I change this to... If I move the add, I think if I move the add down here, it might become apparent. And I change these to A and B. I think we're going to get some funky stuff. Okay, it still works. Well, that's surprising me. Why does that still work? Is that just a coincidence? What if I change these to A and B, but then I make these like... X and Y. That still works as well. Okay, I'm pretty sure this is just working by coincidence. The problem that I think we're going to have is that nothing is scoped, right? So A, actually in this, we should be able to demonstrate it with this. No, cannot find identify A. Okay. Which order was it trying to print in? Okay, add comes first and then main comes second. Why is that? Is it just random? What if I put add at the top? Yeah, add comes second and then this comes first. Viv Beery says, if you define X and Y in main but manipulate them in add, it'll probably work. If there's no scope enforcement right now. Yeah, that's what I'm trying to demonstrate. And Desio Gamer says, fully self or taking help of AI? No AI in this project. That would defeat the entire purpose. Alright, so Aviv Beery says if you define X and Y in main but manipulate them in add, it'll probably work. Alright, so I'll try that. X is 40, Y is 2, and then pass in X and Y. But actually, what if I just don't pass in anything? And then I return X plus Y. That's kind of where we're going with this. Okay, can't do it in that order. Okay, well, at least that works. I guess. Might depend on the order of definition for the functions. Yeah, that's what I'm getting as well. It's funny, I'm trying to demonstrate how it's broken and it's not breaking. But I know it's broken. Okay, we've still got 42. Okay. Last demonstration. Wait, yeah, that was correct. Okay. Right. Exactly. So, we didn't pass anything into add, but we got 42 out. Doesn't make any sense. But that only works because X and Y, like everything is basically global. There's no such thing as scopes yet. So X and Y, even though they're in main, they're just globally used. So when this procedure gets called, it looks up in the symbol table for X and Y. And because everything's a global, it finds them and then returns them. Right? So doesn't make any sense, but that's how it is. Yeah, so we need to fix that. So I'm going to put a note somewhere. Desio Gamer says, I'm learning Python at age of 15. Nice. Good job getting started early. That's good. Moro Philippines Hacker says, is it true? If you're a programmer, then your hair can be lost. Then you can become a bald. I don't know. Maybe. Maybe. I'm not sure. Moro Philippines Hacker says, peace, because of thinking I think for coding. Okay. That's good, I suppose. I'm going to put a comment here. I don't think I actually... Desio Gamer says, I want a shine head. I don't know. I don't care about being bald now. I mean, I've been bald since I was in my early 20s, which is really early. But it does take your attractiveness level down with most women by a couple of points. So it's something to keep in mind. And also, I'm pretty lucky, but some people have weird shaped heads. So that can suck. What's my age? I'm 36. What am I looking for? Oh yeah, comments slash. I'm just not going to support comments yet. I'll support them later. Too tired to do this right now. But I'm going to put in the... Actually, I'm just going to add it here anyway. This should not work, but does... This doesn't really have to be in capitals. It's a bit obnoxious. How do I lowercase stuff in Vim again? Can't remember. I'll just write it again. This... what? This should not be in capitals. This should not work, but does as the symbol table is global. Scopes don't exist yet. By this stream, I mean the next stream, tomorrow. Moro Philippines Hacker asks, why we lose hair when we go to work using our computer? Is there some radiation on the computer? And Desio Gamer, or Desi OG Gamer says, because we take stress and stress causes hair loss. Could be it. And Moro Philippines Hacker says, fact, when we stress for coding, then we can receive and hair loss. Yeah. Yeah, I mean, it could be true. There's quite a few Baldman programmers. I think it's actually unrelated, but that's fine. That is fine. All right, I think despite how meandering that was, we did make some good progress in this stream, so I'm happy with that. You know, we got the... whatever it is that we did this stream done. Oh yeah, the procedures. We can call procedures. And the things, I didn't actually test float registers. Also test float registers. We should probably do that as well. So yeah, these will be the things that I'm tackling tomorrow. So adding scopes and making sure those work, and float registers, fun stuff. So yeah, I'm gonna head off. It's pretty late now. I want to thank you guys for tuning in though on the secret late night stream. Thank you very much, and I hope you have a great day. Okay, all right. Aviv Buri says, thanks for the stream. You're welcome, my friend. Welcome anytime. Desi OG Gamer says, sir, why are you not using VS Code? Yeah, that's, I guess the simplest answer is I don't like VS Code. There's other answers, but I don't like using my mouse. I'll use my mouse when I'm talking and highlighting something, but when I'm actually programming, I don't use my mouse at all. And so VS Code is not great for that. You can add extensions to, you know, you can add extensions to emulate sort of this modal editing that Vim has. But I find that even with that, it doesn't really feel that good. It feels quite laggy. Like when you type in VS Code, it feels like there's a delay. And you probably won't believe me until you use something like NeoVim. Because most people who haven't used, or have basically only used VS Code, they think that it's fast, but you can tell when you type stuff, it's a little bit laggy. But anyway, there are other reasons. It takes a lot of memory, takes a lot of battery. Yeah, but mostly the keyboard thing. I just like using the keyboard. I'm old. My wrist hurts if I use the mouse. So, I'm like a grandpa, basically. All right. I'm going now. Adios, fellas. Have a great day.